In this video, we have these two questions on the board, alright? The second is linked to the first. The first question, find the general solution of y prime prime plus y equal to 1. Then question 2, from question 1, solve the IVP y prime prime plus y equal to 1, y of 0 equal to 2, y prime 0 equal to 7. Alright, so let us look at the first part of the question. We are asked to find the general solution of y prime prime plus y equal to 1. So we have y prime prime plus y equal to 1. So general solution is given as what? General solution, this is a non-homogeneous second order ODE. It is non-homogeneous because the right hand side is not 0. It's a function and this is a constant, right? So our general solution y is equal to yc plus what? Yp. Now, what does this mean? We are going to obtain yc and obtain what? Yp. And how do we get yc? So I'm going to write for yc, we're going to solve y prime prime. It implies that y prime prime plus y is equal to 0, okay? So we use this to solve for yc, the complementary function. And of course, from here we can get our auxiliary equation. Okay, you look at this and you notice that auxiliary equation of this homogeneous second order ODE, auxiliary equation will be given as, let's look at it, n squared plus 1 equal to 0. Yes, n squared from this second order, and then this is y. Take note that the first derivative is not in this function, is that not so? It's not in that differential equation. So this is the auxiliary equation, and in fact, without being told, you would recall from our previous videos, it was stated that there are many forms of homogeneous second order ODE. When given to you, you don't even need to stress yourself solving anything. And so straight ahead, I'm going to write the solution of this. Already I know that this yc will be obtained from a cos nx plus b sin nx. Find out that that is the general solution. So I can say that therefore, our yc is equal to a cos. Our n here, if you do that, is I1. Because if you take 1 to the other side of the equation, you have minus 1. Take square root of both sides, you have square root of minus 1. And square root of minus 1 will give you I. So it's the same as I times 1. Is that okay? So our n here is 1. So this becomes a cos nx, which is a cos x. And then I'm going to use a blue marker, then plus b sin x. Please, as stated, n is equal to 1 here. We have obtained our yc. It's now time we're going to obtain yp. So I will write for yp. For yp, it implies that we're going to obtain the general form of these constants. For yp, it implies that f of x, as given from the question, is equal to 1. So f of x is a constant. Let me indicate it, equal to 1, which is a constant. So because it is a constant, what does it mean? It implies that our yp is going to be taken to be a constant. We say it's c. Recall from our previous videos, we gave a form of a table where we have functions and their yp. They are assumed yp. Is that okay? So what do we do with this yp? Now watch, because this is the main area of focus of this video. It's not to obtain yc that is our problem. It's yp that is our focus. So we're going to say yp is equal to constant. Let's call this equation 1. If yp equal to constant is equation 1, what do we now do? Take note that this is a second order differential equation. So we are going to differentiate the yp 2 times. For this, in which f of x is a constant, this problem is a simple one to get yp. Is that okay? It's a simple one. Now we're going to differentiate this yp 2 times because this is a second order differential equation. So I would write differentiate yp, differentiate y subscript p twice. So follow along as we differentiate. First derivative of this will give us y prime p, and that will be equal to, if you differentiate a constant, you get 0. So this is equation 2. Then we'll move on for the second derivative of yp. Again, differentiate, you get 0. Then this is equation what? 3. Now what do we do with these 3 equations? We are going to substitute it into this differential equation. Is that okay? You would recall at the beginning of this course, ODE, we stated that a solution to a differential equation is one that can be differentiated as many times as the order of that differential equation, which if you substitute it into the differential equation, you should be able to get an identity. That is to say that the equation will balance. Is that okay? So now we've gotten a supposed or assumed YP solution of this f of x, which is 1 here. So all we need to do is to differentiate that supposed YP solution 2 times and then substitute into the differential equation. So we go substituting into the differential equation. Let me write all this down here. Okay, substitute into the differential equation, so dE. Now if I do the substitution, let's see what we're going to get. I'll come over here in place of y prime prime, I'll put 0, then plus, there is no y prime there, suppose there is y prime, I'll also put 0, is that okay? So the next we have is what? Y, and this y is the same as yp. So I'm going to substitute c, and then make it equal to what? 1. Take note that y, which is the same as yp, is equal to what? C. Then here, I'll make it equal to what? 1. Do you see clearly that the value of our c is equal to 1? Therefore, yp is equal to 1. We have obtained yc, and we have also obtained what? Yp. The general solution becomes, the general solution to the dE, is, right, let me use my blue marker. Remember, it's y equal to yc plus what? Yp. So that will now be equal to, what is our yc? Our yc is a cos x plus b sine x. Then plus, what is our yp? Yp is 1, alright? So this becomes the solution. We are saying that y is equal to a cos x plus b sine x plus 1. Alright, if you like, you can bring the 1 first, then plus you add the trig function side. So that's how we obtain the general solution to this problem. We're going to take a short break. When we come back, we'll look at the second part of the question where we'll obtain the particular solution using the IVP given to us from the question. You are welcome from the short break. At this point in this video, we now want to look at the second part of this question. We're told from question 1, we should solve the IVP y prime prime plus y equal to 1. Given that y at x equal to 0, give us 2. And given that y prime at x equal to 0, give us 7. So in the second part of the question, we are to obtain the IVP solution to the first part of the question. What we have here, IVP, means initial value problem, okay? And then there is another that is called BVP, boundary value problem. What is the difference between these two? The way you apply them in solving a particular question to obtain the particular solution to that differential equation is the same, the way you handle it. The difference between IVP and BVP is that the value of x, like here in bracket, the value is 0, 0 is the value of x. Alright, and then these are the value, like this, 2 is the value of y, and then 7 is the value of y prime, that's first derivative of y. The difference between IVP and BVP is that in IVP, the values of x are equal. Is that okay? Then in BVP, the values of x are different. That's just the thing. The way you apply them in obtaining particular solution is the same. Okay, now in the second part of the question, we are to obtain the IVP. There is a particular solution to this differential equation from question number 1. Already, before the break, you recall that we obtained the general solution to be a cos x plus b sine x plus 1, where this a cos x plus b sine x is yc, that is complementary function, and then this 1 is the yp we obtained. So let us proceed and apply this IVP. We're given that y0 is equal to 2. You know, this means the value of x at this point, and then this is the value of y. And then we're also given the IVP again that y prime at 0 is equal to 7. So this is the value of x, and then this 7 is the value of y prime. That is dy dx, i.e. that is dy over dx. This is i.e. okay? That is dy dx. Okay, now how do we handle this problem? Now, we start with the first one. For y equal to 2 when x is equal to 0, it implies that we are going to substitute into this general solution we obtained. Is that okay? Because this general solution gives us the value of y. Is that not so? So coming over here, I'm going to substitute 2 here. To have 2 to be equal to a, and then A is this, and then cos x. So it's going to be cos 0, then plus b sine 0, then plus 1, right? So you see that we've replaced x and y with the values here. Then we can solve. You notice already that this term will give us 0. Is that okay? This part will give us 0. Is that okay? Then this part will give us, let's see what we get there. This part is going to give us 1. Cos 0 is 1. Is that okay? And then 1 times a will give us a. So you notice that our 2 is not equal to a plus 1, which implies that a is equal to 1. Okay? A is equal to 1 because you're going to move this 1 to this 2. You have 2 minus 1, giving us a to be 1. So we've been able to obtain one of the constants, a. Is that okay? Constant of integration, which is a. We are now going to proceed to still do something else. Remember, we're given another condition. That is the first derivative of y. So I'm going to write for y prime equal to 7 when x is equal to 0. We are going to differentiate the general solution. Differentiate the general solution. Differentiate the general solution. The general solution. And so let's see what that's going to give to us. The general solution is y equal to a cos x plus b sine x plus 1. So that means y prime for this, come over here, a cos x, differentiate this cos x, keeping that a constant, you get minus sine x. So that's equal to minus a sine x. And then plus, come over here, differentiate this sine b, sine x, keep b constant. Sine x differentiator will give us cos x. Then differentiate this 1 and then you will get 0. No need of actually writing that. If you differentiate constants. So we're going to substitute now at this point. So it implies that in place of y prime, I will fix in 7 there equal to minus a, then sine x. Alright, that's going to be sine 0, and then plus b cos 0, plus 0, that goes off. Once again, take note that this part is going to give us 0. Cos sine 0 is 0. 0 times minus a is 0. And then this part is going to give us, let's see what we'll get there, 1, because cos 0 is 1. 1 times b will give us b. Therefore, the value of b is equal to 7. So do you see that the IVP or BVP, as the case might be, simply helps us to get the value of constant of integration. A and b here are the two constants of integration for this second order differential equation, non-homogeneous, that we're trying to obtain its solution. Now we've got the value of a and b in this general solution. Is that okay? We can now substitute for a and b there. Therefore, I'm going to write the IVP solution, all right? The IVP solution, which of course, the actual name of that solution is particular solution. Is that okay? You recall that from the beginning of this course, we talked about general solution and particular word solution. So this is now the particular solution. I'll go to the general solution, y equal to, and then in place of a, I'll replace the value. The value of a is 1. So if you put 1 there, let me show all the working. It's going to be 1 times cos x, then plus the value of b is 7, alright, times sine x plus 1. You notice what I did, right? I fixed in the value of the constant of integration. Every other thing remains the same from the general solution. Therefore, the particular solution to this is simply cos x plus 7 sine x, then plus 1. And that is the general solution. Once again, you can choose to write 1 plus cos x plus 7 sine x.